Our next presenter is Claude Roux, whom many of you probably know already. He's been on the program several times. Claude is a professor of forensic science at the Center for Forensic Science at the University of Technology, halfway around the world in Sydney, Australia. And he's going to give us the first of a couple of talks today on time-of-flight mass spectrometry. Claude?
Thank you, Keith. Good afternoon, everyone. I must say that my second talk won't be about mass spectrometry, so one is enough for me this afternoon about that topic. I'm not a mass spectroscopist, I'm only a forensic scientist. I'd like to first acknowledge my co-authors, especially the first two, Jason Lee and Kelsey Woodhouse. Jason basically did most of the work here as part of his honours project, which is a short-term research project at the university. And Kelsey is currently doing a follow-up work on the same topic. So it's pretty much an update about where this research is going, and I have no doubt it will continue for some time. Very briefly, because Cheryl did a great job there, we all know fibers are an important type of trace evidence. A lot of research has been done on a lot of things, and especially when we talk about dye analysis, we are focused on increasing the discrimination of any comparison. I must say that here that fiber dye analysis still remains a challenge for various reasons. Casework examples, I guess, so Harold Dittman is here. Wayne Williams is a big case in the US, but it looks like every country had its big case, seminal case about fiber evidence. In terms of the analysis, I just mentioned before that dye is an issue. I mean, when we deal with color and dyes, quite often we all use microspectrophotometry, and we saw an example before. When we want to move a bit further and get the actual dye analysis, the first problem is to extract the dye. And quite often what people do in most forensic laboratories are thin layer chromatography. But as you know, there are a lot of different techniques that are available. If you attended the workshop on Monday, given by David Hinks and Keith, there were a lot of discussion about various techniques. They talked about LC-MS and including using a time-of-flight mass spectrometer with the LC. We did something very similar, but instead of the liquid chromatography, we used capillary electrophoresis, which is another type of separation technique based on the charge of the analyte instead of other things. The aims or objectives of the project, you've got them here. So basically the first thing, especially the big job for Jason, was to configure the interface, to interface the CE with a mass spectrometer, and then develop a method, see how it would work on extracted dyes, and see how it would work especially with a QTOF, so quadruple time-of-flight mass spectrometry. So why CE? You've got some reasons here. So it can be highly automated. It's much more sensitive than TLC. Small sample requirement. It's pretty efficient. It's fast. The run times are pretty short. It's highly adaptable to a lot of different types of separation modes. And here you've got an example with a UV detection of a dye mixture. And here you have a 50 ppm mixture, and it's not a big deal in something like less than 12 minutes. You've got a pretty good separation. Now, this is the common problem. It works when you have a relatively concentrated solution. Now, when you extract a tiny little piece of dye from a tiny little piece of fiber, we got into these sort of issues with normal CE UV detection, where basically we are right in the noise. So it's why we try to move towards CEMS, where basically after the C separation, we can analyze peaks and get mass spectra from the various peaks. Same way as very similar principle as you have with GCMS, which is used all around the world in forensic laboratories. now, here I show you some of the advantages of adding the MS. So we increase the sensitivity, and obviously we hope that we can increase, first we can get an easier identification because we've got the mass spectra we can work with, and hopefully we hope that we can get a better discrimination. So this is a table. It's probably too small for people at the back of the room, but hopefully if you download the presentation, you've got a few information about recent works, recent trends in CMS, what people have done in the last few years. And once again, this is what we try to do by adding the MS. So we just instead of stopping at that stage where you would have the detection of the analytes here, we'd try to push them somehow to the mass spectrometer. And there are a lot of different ways to do that, a lot of different ways, obviously, to depending on the type of mass spectrometer. So at UTS, we are very lucky because my colleague, Professor of Analytical Chemistry, Philip Double, managed to get a very good relationship with Agilent Technologies. So we have access to a lot of the new toys. And we had access to this machine, so QTOF MS. So if you remember Monday, the workshop, so with the TOF tube here. And basically, we used this kind of ionization adapter kit for the CE. Now, how it works, so I don't have the little videos like Keith had on Monday. I wasn't going to risk that. But keeping very simply, so when you've got the ions coming through here, so you have a first, some kind of mass filtering going on here with the quadrupole. So you can, be interested, pretty much filter the specific ion you want. Then the analyte ions are just going through there. They are pulsed upwards, and they go up to a certain point, depending on their mass, obviously, and then they will go down on the detector, and it will take a longer time or a faster time, depending, primarily on their mass. So we can have a very accurate mass detection, and it's very sensitive. So in terms of the dyes we use for this project, so we use we worked primarily with polyester, so we use a lot of disperse dyes, and we had a few acid dyes. So we bought these dyes from Seba and Sigma Aldrich. For the experimental itself, so we started first with these sort of parameters. So here you've got the parameters for the CE and the parameters for the QTOF MS. So we had to start somewhere. So most of the first part of the experiments were done using these parameters. Then it's pretty much the job of Kelsey. She's been working on trying to improve the buffers. So she changed a lot of things with the buffers. So I won't read all that. You've got that on the slide. But so she used different types of buffers there, some non-aqueous buffers as well. So she's been very busy playing with the method development. Then she focused on ammonium acetate buffer, and she changed the concentration. She added some acetonitrile, changed the pH. And ultimately, she found that that type of buffer, was the optimum for the kind of experiments we were doing. So ultimately, these are the optimum parameters that have been used for this research, or at least most of it. And these are the parameters for the mass spectrometer. Okay, a few results. So here you've got an extracted compound, electrophoregram of metanyl yellow, and it's a 10 ppm mixed standard, and no big problem to get a mass spectrum from there. A similar thing with acid green 25, again 10 ppm, and no big deal to get a mass spectrum. When we go to a dye mixture at 10 ppm, So here again, we've got a few things here going on, but ultimately it's not, again, we've got a pretty relatively good result here in terms of detecting this dye mixture. Now, if you remember the 500 ppb I showed you before with the UV detection, which was pretty much the noise, so this is what we have now this time with EMS. So you can see immediately visually the sort of big improvement we have by moving towards MS after CE. Now, if we push to 20 ppb, so we still retain one of the dyes, tyrosine yellow, which is still detected. Now, there were some experiments to, deal with linearity, investigate linearity, and limit of detection, and all that was done in triplicate. And you can see, pretty much the big advantage of CMS when you compare to CEUV, both in terms of, the linearity and the detection limit. I think that's not a big surprise. And here some graphs showing again the linearity with pretty good correlation coefficients. So very good technique for that purpose. We did some experiments about precision. So there were 6 runs here, and again here you have the overlay of the 6 runs with 10 ppm. And if you prefer that in terms of a numerical table, you can see obviously there is a bit of variation depending on the dye, but still you can see a big improvement or some improvement between when you go from a CEUV detection to CMS. Now the big, I don't want to play with the word and say an acid test because with some acid dyes, but that was really trying to see what it would be when we move towards a single fiber extraction. So we started not necessarily with a single fiber, first with thread, which is the photo you've got at the bottom, but ultimately we did experiments with single fibers. So you've got here the operating procedure. There is nothing really special here. As Keith mentioned on Monday, it requires a bit of practice and sometimes an art to do that. And I was very lucky, so students can do that instead of me. So here you've got some results based on 5 millimeter of a yellow fiber, and here it was a yellow fiber dyed with a tyrosine yellow dye, and you can see we can have relatively good results, so we can detect that dye. We have the mass spectrum. The same thing with a red fiber with tyrosine red, and again extracted from a 5 millimeter fiber, a polyester fiber. So at this stage, this research is going on. What we want to do is maybe to pay a bit more attention to the mass spec source and try to, so we've got some plans with Agilent to try an APPI source, possibly further optimize the CE parameters. There were some effects that we have to investigate due to the MS source and CE positioning. Or even possibly move towards another type of MS that, again, we have access to thanks to Agilent triple quad mass spectrometer to further increase the sensitivity. I must say at this stage, one thing that we really need to do as well, and it's always the problem with these sort of fiber projects, we've got access to a large variety of techniques in fiber examination. So each time we try a new type of technique, we always have the question, does it bring any value to the scheme of examination we already have? So I'm very keen to do further experiments and have access to some samples that maybe people have already analyzed through a full sequence of analysis, so we don't have to reinvent the wheel, and then we could take that further using this technique. So if you have access to such samples, if you you think that you could assist and contribute, yeah, please talk to me. I'm sure we could find an arrangement, but I would be really keen to see from a forensic viewpoint really how much more discrimination we bring. Another thing as well from a forensic viewpoint is because if we add the technique which is so sensitive, then we have the question whether we bring some contaminations. Maybe it's not the best word, but at least some contribution from environmental conditions, such as washing powders, sun exposure, tumble drying, fabric softeners, etc. And there was a whole list on Monday in the workshop. So that can be positive or negative. I mean, it can be positive if it's something we can actually identify and use that as a further point of comparison, but it can be negative because it can lead to false negatives in a case because we've got new peaks or things like that. The other things again that we try to do more research to try to see the effect of increased extraction times or increased temperatures. I guess we could go never-ending in terms of the method development. And I mentioned the assistance required before. So please, if you have any access to such samples and you would like to contribute, you can talk to me. So in conclusion at this stage about this work, so we think that CMS has big advantages over normal CEUV. So it's more sensitive. It showed that a lot of parameters such as linearity, limit of detection, etc., are much better. It looks like it's a reliable system for the identification and discrimination of the dyes. It's reproducible. And it's at least theoretically a feasible and efficient alternative to current method that we have. But obviously we need to do more work, and hopefully at some stage it has the potential to be useful in forensic casework and really try to crack this issue of dye analysis. So a few acknowledgements here. So Agilent Technologies, especially Chris Furakers, who's a technician at working with Agilent Technology. Dr. Susan Bennett from the New South Wales Police Force, who assisted with some samples. Professor James Robertson at University of Canberra, and the Australian Federal Police staff who helped as well with the project. And again, if you don't know what to do next year, or even if you want to contribute to the project with samples and deliver the samples yourself, we've got this fantastic Australian-New Zealand Forensic Science Society Symposium in September 2012 in Hobart, which is a very nice little place in Australia. It's very, very green, very different from the rest of the country. And thanks for listening.
The schedule for us to have the floor open for questions for about 15 minutes now. So I'll open the floor. I think we're supposed to have a microphone, but I can't. There's too many photons in my eyes. I can't see anything out there. So are there any questions from the floor? Yes.
I had a question for Claude. Do you see the value of the technique as more for identifying the dyes or for quantifying the amount of dye?
The first advantage is really the increased sensitivity, because when we really extract a tiny piece of fiber, we quite often have this problem of being below the limit of detection or in the noise or very close to it. So that's the first thing. Then obviously, you are right. The ability to identify the dye would be another big advantage. Now, I can see the next question. The really big holy grail there in terms of dye with fibers would be the analysis of the dyes in situ without having to extract the fiber, because whatever technique we use, if we have to start by extracting the dye, we already have a big limitation there. whatever technique we use. So, thinking about your experience with Raman, and all the work that has been done with Raman, I mean, it's another way to look at it, and I guess that would be another avenue for research to look at the analysis of dye in situ.
Other questions for any of the speakers? Okay, you can't get out because I have questions. Moderator's always supposed to have questions. I always do this with my students, and they probably feel the same way. Why? Dale, I noticed in your green fiber, the largest differences were at long wavelength. The differences were smaller at the shorter wavelength. Is that a structural feature that we get the big differences out at the long wavelength?
That's a good question. I don't know the answer to because I have not characterized these polymer films yet. That's actually a film.
Mm-hmm.
So I don't really know the orientation of that film. I don't know enough information yet about how it's produced to know the answer to that. So
Okay.
but with the conjugation in the visible range is not abnormal to see a larger shift in the red, a bathochromic shift in the red.
Okay. Might be a good question for your final exam. Cheryl, red. Why? Being from NC State, I wanted to know why you picked red when Dr. Morgan might have picked another color.
That's the exemplars we were given.
Okay. And there was a second part to that. Any ideas why there was a problem in classifying reactive red too?
We did notice when we looked at the structures that it was like an isomer of each other. So we were wondering if maybe that's why it was really hard to classify one or the other.
I guess one of the things that I think about when most red dyes have two absorption peaks in them. So by picking red, you had two peaks already. You find a lot of blues and yellows, they only have single peaks. So you started off with a little more difficult classification scheme there. Claude, it appears as if you were running in negative ion mode, is that correct?
Yes.
The difference between acid and dispersed dyes, because the acid dyes are already charged negatively, and the dispersed dyes, obviously there's no problem in charging them, and we've seen the same thing. There's no problem charging them to get them negatively. So I guess that's just a comment. The next question is, do you know, and you may not have done this yet, can you run cationic dyes, basic dyes, in your capillary electrophoresis instrument? I'm guessing you probably have to change the mobile phase.
Yeah, we would have to change that. I don't see there would be a real problem there.
Okay. Other questions from the audience? Yes, Steve.
I'm Steve Morgan from the University of South Carolina. In response to your question about the red dyes, since I helped provide some of those samples to him, and he's a collaborator in our current project, I had to know a little bit about it. Turns out that I think the impetus for that project came from the Indiana State Police, who are interested in red dyes because there are gangs that wear red scars, and they were finding these fibers in, possibly in related crimes, and they were trying to make a connection.
Okay. Since I went to Purdue, does that mean they go to IU?
No comment.
Yes.
I just have sort of a comment for Claude, actually. I'm glad that you brought up the ability to add discrimination, and unfortunately I don't have fibers to provide for you. But my understanding, and based on research that has been done, that with the current scheme, the discrimination ability is very, very high, like 99% or something like that. So given the potential for added discrimination, how does that balance with the cost to the laboratory for such instrumentation?
Yeah, it's an excellent question. I think it's really, I guess, that would be pretty much case specific, really. If you have a specific case, whether it's really high profile, you really want to go to the end of it, for completeness purposes, as they say, or you have a specific, specific problem because it's a specific type of fiber. There is some kind of industry information you have, and you think that would really bring, something to the case. But I agree. I mean, on a daily basis, this pool of techniques available are already so powerful. And I guess it goes back to what I mentioned to Chris before, that I still really the big thing with dye and fibers is really the analysis in situ. But whether we completely crack that, I don't know.
Other questions? Yes, Bill?
I had a question for Dale. I'm Will Randall with the Missouri State Agricultural Lab. On your the dichroic variations and the absorptions in the different polarizing directions, I know that the polyester you were looking at was mounted in a refractive index liquid near the perpendicular direction, with the lower refractive index direction. And when you look at the other direction, that was the refractive index difference between the parallel and the liquid was greater, so there was more contrast there. I was wondering if that difference in that contrast, if you're aware if that had any impact in and of itself on the absorption that you saw between the two directions.
That's an excellent question. That's one thing that I'm looking into to see if the match point of the birefringence to the liquid or to the fiber is, we already know that there's going to be scattering effects when the refractive index don't match. But that is something I'm going to look into. I did not change the oils. I try to keep them all in the same oils. I've done this for several different types of fibers, nylons that are multicolored blues, wool, and with polyester being such a high birefringence, and it's going to cause us the most trouble, that's the first one I'm going to look at. But my guess is that we are going to reduce some scattering, but the dichroism will still be there. To what extent, I'm not, I don't have an answer for you yet. But I think that we'll still see the linear dichroism there.
Yes.
Sorry. It would be interesting to see Dale and Cheryl get together and see if dichroism could help to distinguish some of the fibers or some of the dyes that couldn't be distinguished in your work.
Let me just comment on, we have looked at some acrylic fibers where the very low birefringence, so we don't see much change. And there certainly are effects if you would ideally always have your fiber mounted in an index oil that is matching the index of the fiber. That's not a lensing effect as well as reflection losses. But the way to cheat is just do acrylics.
If I can add to that, the acrylics and the monocrylics that we were looking at, they're very, very faintly yellow, and they're typically very, very difficult to get a spectrum of, and we were still able to get good, useful data out of it. Then comparing those fibers side by side, they look the same, but we're able to differentiate them.
Other questions? Everybody's looking for a break. Okay, we're going to break for now 20 minutes. We will reconvene at 4:30 for the next portion. Thank you.
Great, thank you.